Located underground between the borders of France and Switzerland, the Large Hadron Collider, the LHC, operated by CERN, has made astounding discoveries. The Large Hadron Collider is the most potent particle accelerator ever created. Without a doubt, the latest improvements to the collider will produce findings that fundamentally change our understanding of the laws of physics. The LHC particle accelerator has helped physicists to make astonishing discoveries regarding the fundamental nature of the cosmos. The year 2018 saw the conclusion of the second experimental run at the Large Hadron Collider, which revealed new revelations about proton structures and the Higgs boson decay process. The Large Hadron Collider helped scientists discover the Higgs boson particle over 10 years ago. After 10 years of research, the incredible research wonder got ready to slam protons together once again, but this time with unthinkable energies, to reveal new mysteries about the nature of the cosmos. It took the scientists more than 3 years to modify the Large Hadron Collider in preparation for its third run, and the effective particle collider restarted in April. According to CERN physicists, the Large Hadron Collider will run at a record-breaking energy of 13.6 trillion electron volts after more than 3 years of maintenance and modifications, enabling discoveries in particle physics. The 16.8-mile-long Large Hadron Collider at CERN helped physicists in the discovery of the Higgs boson particle and its associated energy field. This discovery is said to be crucial to the expansion of the universe following the Big Bang, which occurred about 13 billion years ago. The Large Hadron Collider is mainly used to test particle physics theories, especially those related to the Standard Model, the existence of dark matter, dark energy, and the quantity of matter relative to the antimatter remain mysteries despite the Standard Model's capacity to explain nearly all particle physics evidence. The LHC was built to provide answers to these kinds of issues. In July 2022, with the machine's most powerful beam of energy returning after a 3-year sabbatical, the particles, a new type of pentaquark, and the first pair of tetraquarks were discovered. These fundamental particles, known as quarks, exist in 6 flavors: up, down, charm, strange, top, and bottom. They frequently combine in pairs or trios to produce hadrons that look like the protons and neutrons that make up atomic nuclei. They can also combine to form tetraquarks and pentaquarks, although this occurrence is very rare. Even though physicists predicted the discovery of these peculiar hadrons 60 years ago, the LHCb and other experiments have only recently provided conclusive evidence of their existence. Most rare hadrons found in the last 20 years have a charm quark and charm antiquark together with a down, an up, or strange quark, or one of its antiquarks as the remaining 2 or 3 quarks. Yet, over the last 2 years, the LHCb has uncovered a large number of new hadrons. 2 years ago, the collaboration discovered 2 tetraquarks with open charm, made up of charm antiquarks, up quarks, down quarks, and odd antiquarks, as well as a tetraquark made up of 2 charm quarks and 2 charm antiquarks. The first tetraquark with a double open charm was found last year, made up of 2 charm quarks, a down and up antiquark, and 2 charm quarks. A charm quark exists in an open charm particle, but no corresponding antiquark does. Recently, some further unusual hadrons were also discovered by the Large Hadron Collider. An analysis of the decomposition of negatively charged B mesons revealed the first hadron form called a pentaquark. It is composed of an up, a down, a weird quark, a charm quark, and a charm antiquark. It is the first pentaquark to be linked to a unique quark. Compared to the 5 standard deviations necessary to announce particle detection, the result is statistically significant by 15 standard deviations, which is a major increase in particle physics. The second type is a tetraquark, with 2 electrical charges. It was found alongside its neutral counterpart during a combined investigation of positively charged and neutral B meson decays. This tetraquark with 2 electric charges is an open charm tetraquark that comprises an up quark, a charm quark, a down antiquark, and a strange antiquark. The newly discovered tetraquarks are the first pair of tetraquarks having a statistical significance of 6.5 doubly charged particle standard deviations and 8 neutral particle standard deviations. A worldwide network of scientists now has the opportunity to once again search for the strong force that holds atomic nuclei together after major repairs and modifications. The electromagnetic, gravitational, weak, and strong forces are the other 3 forces that affect particle decay. With its current state of operation, the Large Hadron Collider is performing the most energetic particle collisions ever. It's thrilling to watch as the CERN physics researchers look for further details on the so-called God particle, the Higgs boson, and proof of the dark matter. Another new particle is even more fundamental than the Higgs boson that has been found, according to CERN physicists. In research carried out at the Large Hadron Collider, this new particle, dubbed the X17, was discovered in the decay of helium nuclei. A group of Hungarian physicists originally proposed the existence of the X17 particle in 2016, claiming to have seen it while conducting research with unstable helium nuclei. Since then, many teams have made an effort to verify these findings, with varying degrees of success. Similar outcomes have been recorded by some, while others have detected no trace of the particle at all. The possibility that the X17 particle could be a revolutionary kind of fundamental particle that deviates from our present understanding of physics is what makes it so intriguing. This would require us to reevaluate our entire concept of the universe, from the smallest subatomic particles to the greatest cosmic structures. Of course, some skeptics question the X17 particle's existence and contend that the experiment results are only a coincidence. But as someone who enjoys discovering the intricacies of the cosmos, we can't help but be thrilled at the thought of a brand new particle that might enhance our comprehension of the world. Due to the machine being reactivated after a 3-year pause, running at record levels and continuing for the following 4 years, various conspiracy theories surfaced on social media in the weeks leading up to the Collider's 3rd launch. Some conspiracy theorists fear that the LHC will give rise to a portal to hell, or a parallel universe, from which there is no way to escape. These speculations about CERN have been around for a while, ranging from the openings of black holes to human sacrifices on the grounds. All the speculations have revolved around lots of weird stories, so much so that it looks like the conspiracy theorists have been watching a bit too many sci-fi shows or Doctor Strange. One classic example of a conspiracy theory on Twitter was written by a verified astrologer who asked if anyone has felt the impending massive shift because CERN was going to power up the LHC, which will cause the Earth to switch timelines in July 2022. He said the LHC powering up would cause a portal to be opened up to the unknown world to infiltrate this planet. Another theorist also noted that he had made his research and the effects of the LHC powering up will cause 10 times more Mandela effect. These effects will be due to high voltage levels from portals that should remain closed. Even if it is outrageous to believe that by vibing, you can evade being sucked into a parallel universe through a portal created by the LHC, let's consider the conspiracy idea for a while. To be clear, one may speculate that these parallel universe theories are based on the possibility that the Large Hadron Collider will find evidence of possible alternate universes. According to CERN, there's no possible way to conduct a test to check for the possibility of an alternate dimension. At least, if it existed, there will be pieces of evidence or biological footprints of particles. According to these theories proposing more dimensions, weightier versions of these particles might exist in those realms, similar to how atoms have high-energy excited states and low-energy ground states. These detectors would be able to detect these particles, known as Kaluza-Klein states, because they would have similar properties to the standard particles, but with a far greater weight. A Z or W-like particle that both carries electroweak forces with a mass 100 times greater in size were to be found by CMS or Atlas. This would be solid evidence of the possible existence of a parallel universe. Only at the high energies reached by the Large Hadron Collider can these heavy particles be observed. There is also a chance that the LHC will create incredibly fleeting and tiny black holes. These tiny, barely visible to the human eye black holes could be signs of the reality of these alternate universes. These tiny black holes cannot engulf the entire world and would crumple in on themselves in less than 30 seconds. According to CERN, the mystery surrounding these tiny black holes are more like particles created by two or more proton pairs with the energy of a little ant colliding. The black holes found in space are far heavier than anything the LHC can ever produce. Now, what was the reaction of these conspiracy theorists when they saw that we didn't shift universes, nor were portals being opened up and sucking humans in? I guess they looked the other way when they found out their ideas were almost ridiculous. Many people do not realize how significant the CERN Hadron Collider agenda is. Some theorists think that the results of the LHC starting up are not immediate, but will unravel as time passes. According to CERN, discovering the particles, phenomena, and even solutions to them may be a significant missing piece in the puzzle of life that we are yet to unravel completely, like how it can be, its essence, and its ultimate end. All of the discoveries made so far have only been centered on about 4 to 5% of the data collected by the collider over its lifetime. Physicists are preparing for the fourth phase, which will start in 2030, according to the press release from CERN. We anticipate seeing more of these discoveries. The discovery of the X-17 particle and the God particle is enough proof of the extraordinary power of human curiosity and exploration. It serves as a reminder that there is still much to learn and comprehend about the world we live in, and that when we get together to work toward a shared objective, we can achieve incredible things. And that brings us to the end of this video. We hope you enjoyed this video and learned something new today. And as always, keep exploring!